Section 4.2 is on solving quadratic equations by graphing. A quadratic equation is an equation of the form ax squared plus bx plus c equals 0. The solutions, or the values of x that make it true, are called the roots of the equation. In order to find the roots of the equation, we need to find the zeros of the related function. That is, what are the x-intercepts of the graph? So all of these things are kind of related to each other. A quadratic function is in the form f of x. And so here's an example of one. F of x equals x squared minus x minus 6. Its zeros are negative 2 and 3. The related quadratic equation is x squared minus x minus 6 equals 0. In other words, when is f of x equal to 0? And its roots, or the x values that make it true, are negative 2 and 3. The x-intercepts of the graph are negative 2 and 3. And as you can see, it's all kind of the same thing. So to solve a quadratic equation by graphing, so this is the quadratic equation, it equals 0. We're going to graph the related function, the f of x thing, and find its x-intercepts. Where does it cross the x-axis? So let's take a look at a couple examples here. Oh, before we do that, a quadratic equation can have two real solutions, so it can cross the x-axis in two places. It can have one real solution, crosses the x-axis or actually just touches the x-axis in one point, or it can have no real solutions, and that is it will never cross the x-axis. Here's our first example. We need to solve x squared plus 6x plus 8 equals 0 by graphing. So in order to do this, I first want to find the vertex. So recall the x of the vertex is negative b over 2a, or in this case, negative 3. And then to find the y of the vertex, I'm going to plug that in to the function, plug in negative 3. So that's going to be negative 3 squared plus 6 times negative 3 plus 8, or 9 minus 18 plus 8, or negative 1. So my vertex is the point negative 3, negative 1. And I'm going to go ahead and make a table of values. And I will put that in the center of my table. And I'll choose two x values smaller and two x values larger. Okay, so plugging in negative 5 is going to give me 25 minus 30 plus 8, or a positive 3. Plugging in 4 is going to give me 16 minus 24 plus 8, or 0. Plugging in negative 2 is going to give me 4 minus 12 plus 8, or a 0. That's nice. I'm starting to see my symmetry. And plugging in negative 1, I will get 1 minus 6 plus 8, or 3. Okay, so let's go ahead and graph that. So negative 5, 3, 4, 0, negative 3, negative 1, negative 2, 0, and negative 1, 3. And recall that what I'm looking for is where this graph crosses the x-axis. And I can see that happening right here at x equals negative 4, and right here at x equals negative 2. So my two solutions are x equals negative 4 and x equals negative 2. Now, one other thing I want to point out is notice that in our table, when x equals negative 4, y equals 0. That's not a coincidence. It's supposed to be that way. And when x equals negative 2, y equals 0. That's another way to figure out that you do indeed have your solutions when y equals 0. Let's take a look at our next example. Here I have x squared minus 6x plus 4 equals 0. Let's go ahead and find our vertex. So negative b over 2a is going to give me an x of 3. And then plugging in 3, I'm going to get 9 minus 18 plus 4. for a -5. So making my table of values here. I'm going to put 3 and -5. And I'll choose 2x is smaller and 2x is larger. Go ahead and plug those in. So plugging in 1, that's going to give me 1 minus 6 plus 4, which gives me a -1. Plugging in 2, I'll get 2 minus 12 plus 4, which gives me a -4. No, it doesn't. Hold on. Wait a minute. 2 squared is 4. Sorry. Minus 12 plus 4. There we go. That's going to give me my -4. All right. Sorry about that. Plugging in 4 gives me 16 minus 24 plus 4, which gives me a -4. And plugging in 5 gives me 25 minus 30 plus 4, which gives me my -1. Now I can see right now I have a little bit of a problem because all of my y values are negative. And in fact, let's go ahead and just graph that to see what it looks like here. So 3, -5, 2, -4, and 1, -1. Okay, so from my values, it's not crossing the x-axis yet. So what that means is that I need to choose some more values. I need to keep graphing until I can see that it's heading up, but it hasn't quite gotten there yet. So I need to do another x that's smaller and another x that's larger. So plugging in 0 is going to give me a 4, and that'll be the same down here when I plug in 6. So let's go ahead and graph those points. So 0, 4, and 6, 4. Now I can see that my graph does indeed cross the x-axis, but unfortunately it doesn't cross at a nice point. It looks like it's between 1 and 0, and it's between, what would that be, between 5 and 6. And I don't know exactly what those are, but that's okay. So I'm going to write my answer, my two solutions, as x is between 0 and 1, and x is between 5 and 6. So it's some irrational number in between there, but I don't know exactly what it is by graphing. And actually you can notice that in the table here, that right here, my y's go from being positive to negative or negative to positive. So somewhere in there, there's a 0. And the same thing in here, somewhere between -1 and 4, there is a 0. So that means that my solutions are going to be between 0 and 1 and between 5 and 6. Actually, that's why graphing is not a really precise way of solving a quadratic equation. And our last example here says use a quadratic equation to find two numbers whose sum is 4 and whose product is -117. So I need two numbers that add up to 4, and the same two numbers have to multiply to -117. Well, so I can't really solve that system of equations as it is because one has addition and one has multiplication. But what I can do is some substitution. I'll solve this one for y by subtracting x on both sides, and then I'll take this and substitute it into there for y. So that's going to give me x times 4 minus x equals -117. Distributing 4x minus x squared equals -117. Oops. And I always want these to be equal to 0, and I like to keep my x squared positive, so I'll do this. I'll do x squared minus 4x minus 117. Now, all I need to do is solve that, and that will give me the two numbers. So that's a little complicated to graph. I'm noticing it has a y-intercept of -117. I really don't want to graph that, so I'm going to do that on my calculator. So let's pull up the calculator here. And let's put that into y equals. So I have x squared minus 4x minus 117. And let's graph that and see what it looks like. So remember, what I'm looking for is, where does this cross the x-axis? Well, real clearly I have one right here, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, so -9, but I don't see over here. So I think I'm going to need to change my scale. In order to change my scale, in other words, I need more x's. I'm going to hit the window button, and I would like my x max to be a little bit bigger. So I'm going to make that 20. I'm going to make my x's go all the way out to 20. And now let's hit graph again and see what that looks like. So there's my -9. And there's my point right there. And I could either count that, or let's go ahead and let's take a look at a table. To get a table, I'm going to do second graph. Okay. And notice that it has x's in here. Actually, let me check my table setup. Oh, here we go. So this is table setup. I did second window, and what I want to do is I want to be able to choose my independent variables. I want it to ask me what x's I want. So I'm going to go down here to, till that's flashing, go over to ask and hit enter. Now when I go to my table, it will let me choose the x's that I want. So I'm pretty sure I had an x of a -9, so let's put that in. And sure enough, that gives me a y of 0. And then there was something out beyond 10, so let's try 11. So when x is 11, I'm not quite at 0. When x is 12, not quite at 0. X is 13, I'm at 0. So my two solutions are x equals -9 and x equals 13. And, oh, -9 and 13. So in this section, we took a look at how to solve quadratic equations by graphing. You basically graph the related quadratic function and see where it crosses the x-axis. And for those problems that you have to do, like this last example here, go ahead and do the graphing on your calculator, because you might end up with a very large number, something that's just way too big to graph.